Okay, hi everyone. It's 12:30, so we're going to start. I have the pleasure today of introducing Jason Hong, who's an associate professor at Carnegie Mellon University, and specifically he's in the Human-Computer Interaction Institute, so he is from my community, so I'm very excited to have him here. He has won numerous awards, too many for me to list, including a Sloan Fellowship. He was a fellow at the New America Foundation in DC, and he's also co-founded a company called Wombat Security Technologies, which was recently acquired, last month. And so he has many accolades that I have too many to list. And in the words of his own brief bio, he's a pretty awesome guy. So I'll leave it at that. I'll let him tell you about his research in privacy and security.
Thanks. Just to set the context, basically there was a long bio, a short bio, and a really, really short bio. So that's where it fits in. At least I hope my daughter thinks that I will be an awesome guy. So, thanks for having me here. I want to tell you sort of the basics of what I'm looking at by starting by telling a vision of where I think we're going. I've been working on these sensor-based systems and mobile systems for about 15 years now, and I think that in the near future, our smartphones are going to know almost everything about us. They're going to know how well we're sleeping. They're going to know how green we are. They're going to know whether we're depressed or not. Now, I'm saying this for three big reasons. The first reason is that smartphones are already pervasive. Last year, over 1 billion smartphones were sold. In the US, it's over 80% penetration rates and 30% worldwide. But the other reason for this is that smartphones are also the most intimate devices we've ever created. Here's some fun facts about millennials. 83% of them say they sleep with their phones. 90% of them say they check them first thing in the morning, and 1 in 3 of them admit to using them in the bathroom. Right? But it's not just that the devices are intimate, it's also that the data is intimate. So here's some screenshots from my smartphone, and if you just took a look at my contact list and call log, you could easily tell who I know, how close I am with them, who I care about a lot too. Right? So you could easily tell who my wife is based on the most number of calls and also length of the calls too. Based on the photos there, the geotag photos, GPS, you could also tell where I've been. And based on the rich array of sensors, you could also tell what kinds of activities I do and also what's going on in the room around us. So I think that this is offering us this really incredible opportunity, which many of us are already trying to push on, which is that we're essentially creating a worldwide sensor net with these kinds of devices. And we can now understand human behavior and activity at a fidelity and scale what's never been possible before in all of humanity. Right? So again, we can do a lot of really good things with this. Again, as I was mentioning, sustainability. We can understand cities at a scale and fidelity that we've never been able to do before, depression, health, and all this other stuff. But this also leads to the other side of the problem, which is privacy. How do we know what people are going to do with this data? And so this is the fundamental tension. On the one hand, the same data can be used for good, and on the other hand, it can also be used for not so good purposes. And these aren't just hypothetical concerns, as many of you have already known. So, for example, Pandora was under investigation by the federal government for many years for sharing your location, gender, phone number, unique phone ID with about a dozen advertisers not making that clear to people. Facebook Messenger was recently disclosed for uploading your entire call history to their servers. And in fact, the Facebook app itself also uploaded your entire contact list to their servers without letting you know. And there's even a Holy Bible app we found that gathers location data and your unique phone ID too. So apparently even supreme deities need help from Apple and Google to figure out where you are. So here's an overview of the work that our team's been doing for the past 7+ years. We've been looking at it from a lot of different angles. So human factors, systems, machine learning, networking, software engineering, and so on. So I want to give you a whirlwind tour, an overview of all the different kinds of work that we did. So it's going to be more of a breadth kind of talk rather than a depth talk here, but happy to answer more questions that you might have afterwards. I'll start somewhat chronologically by talking about our first projects in smartphone privacy. So the first one is privacygrade.org. This is a website where we graded 1 million+ apps as to what the privacy issues were. Then my colleagues did a system called Protect My Privacy, where we're looking at how we can intercept sensitive calls at the operating system level and help people make better decisions. Afterwards, I'll go to a process-oriented view of these apps, where we look at how do people develop these apps? What do developers know? And then the next part is, well, can we try to infer what the apps are trying to do with your data? So, for example, after it's been uploaded to the App Store or once it's on your phone, how do we know what it's actually trying to do? And the third part is enforcing it. How do we protect the devices, the data that's on your devices too? And then at the end, I'll also talk about some of the ongoing work that we're doing, and would also love to have feedback because it's still in the early stages too. Feel free to ask clarification questions too throughout. Yeah.
On protect by privacy, when you say intercept calls, you mean operating system calls or phone calls?
Oh, operating system calls. Yeah, the system calls. Okay. I'll also sort of jump to the end too. So some of the key ideas from our work. So after we've been working in this area for so long, what are sort of the synthesis, the big ideas we've had? One is that I feel like we really need to have an ecosystem of privacy. Right now, there's too much burden on us as individuals to make all these decisions. We have to figure out what is the behavior of this app, how do we do this configuration, and what's the right thing to do. And this also is sort of like a libertarian view of things. So we should all have freedom to do things, which is good. But the problem is that it just sort of gives all these companies an excuse to say, hey, we gave you all the user interfaces and you just didn't configure it correctly. And it's just a huge burden on all of us right now. And so my argument is that we really need to figure out how to push more on developers, the operating systems, the third parties, and government organizations to help them shoulder the burden of work too. And particularly looking at how to offer developers clear benefit for doing this work. So the problem right now is that developers, they can do some of this stuff if they know, if they're aware of it. That's also another big issue. But there's not a lot of benefit for them to do so right now. So I'm going to talk about some of the strategies we've done to try to address that issue. Another big one is that I think we should push more on purposes, which is why the app needs data. So today we can easily tell what data the app is using and also where it's going, but a little bit of where it's going, but not so much why it's using it. So this is actually, I think, a really amazing point of leverage that we can have if we can figure this out. Or, maybe we should even have developers try to be a lot more explicit about that too. So I'll show you some of the early work we have there. The last one too is that I think that these third-party libraries are a powerful point of leverage too. So I'm actually not sure if people know what I mean when I'm talking about these libraries. So how many people here are more like these computer scientists or technologists that understand what I mean by that? Okay. Just for the people who aren't as familiar, imagine that these apps are made out of Lego pieces, and some of these Lego pieces are made by Twitter or Facebook or other things. And so those are the third-party libraries. And it turns out those are actually the ones that are trying to get a lot of your sensitive data. So I believe that these libraries give a lot of insight about why your data is being used and where it's going. And we also found out, I'll show you some of the results, a lot of these smartphone apps collect data only because of these third-party libraries. So again, I think that it offers us a really powerful point of leverage for improving the state of the art. Okay, so let's go on to Privacy Grade. This is a website. You can also check it out. The whole goal we had for this was to improve transparency of what's going on with these apps. So essentially, we downloaded 1 million+ apps. We applied some privacy models, which I'll get into a second, and then we assigned grades of A, B, C, or D to these. So for example, you can see A+ means it doesn't use any sensitive data, so that's lasers. Instagram was pretty good. Temple Run, Angry Birds, drag racing, and so on. So if you drill down and click on an app, so here's some more information about drag racing. Here's the app description as you would see on Google Play. We also have some privacy analysis. This is the part that the CMU lawyers insisted that we put in here. So basically it's saying that this is not our opinion, this is based on our method, and so on. So basically it's sort of like boilerplate for please don't sue us. And then we also have sensitive permissions used by this app. So what the permission is, we have a human description of what that is, and also the why part. And the why part is what we added in. And this is based on, again, the third-party libraries. So for example, it says this would read phone status and ID, and then it explains what that is and why it's using it. So for example, for analytics. You can scroll down, you can see that it uses more permissions, so network access, precise location, and scroll down some more, there's even more permissions, and then it gets to the interesting part, the third-party libraries used by this app. So for example, Flurry, Chartboost, Millennial Media, SponsorPay, Amazon, GetJar, and so on. Yeah?
Is this based on static or dynamic analysis?
Static analysis. It turns out finding what libraries an app uses is actually pretty easy to do. And sort of the insight here is that these libraries give us a really good hint as to what's going on. So for example, if we know that location data is used, and it's used primarily because it's a request inside the Flurry library, and we know Flurry is an analytics library, then we could say it's probably using your location data for analytics. So it's just using that kind of simple chain of reasoning there. So I also want to give you a quick crash course in one of the most important concepts in human-computer interaction, which is mental models. And so you'll see in a second why this matters. This is actually a picture of my brother's Nissan Maxima. And so you can see the gear shift here. He was actually driving his car wrong for over a year before I pointed out what he was doing wrong. So does anyone have any guesses what he was doing wrong? Yeah?
He was in first the whole time.
No, actually it wasn't first, but it's close.
Okay.
It was in second.
Second? No, so it turns out he was actually in third gear, because you notice that every one of these is in a single row, but third gear is the left side and drive is on the right side, right? And it turns out this is, I also talked to other people. He's not the only person to make this mistake. Right, so you can imagine that he didn't realize that 3 and drive were actually different. Now, what's interesting here is that if you look at this the older Nissan Maxima, it's impossible to make this mistake because there's only a mapping of 1-to-1 here. So every row represents one single thing. Now, I should also point out I am the younger brother, and my brother is actually a pretty smart person. In fact, he drives a Tesla Roadster, and I don't. So now he does. So he could make an argument he's much smarter than I am. Now, so this goes back to mental models, how people think something works. And this is sort of the same idea as to how we applied it for understanding what the privacy implications were for apps. So for example, we're using crowdsourcing to compare what people expect an app to do to what it actually does in practice. So for example, most people don't expect a motorcycle game to use microphone data, but in reality it does. And so in this case, there's a big gap between people's expectations and reality. And so we consider that to be a big privacy problem. In contrast, if I told you Google Maps uses location data, it's like, okay, well, that's not surprising. So we would say the expectation there is very clear. People already know it uses it, and it does. And so because there's a small gap, we would consider that to be less of a privacy problem. So this is sort of like our way of trying to measure implicit informed consent. Okay. Now, what we specifically did was ask questions like this. So it's a little bit like Mad Libs, if you ever played that child's game. So how comfortable are you with drag racing using your location for ads? And then we manually label these purposes by examining the third-party libraries. And so again, we had 4 major categories: social media, ads, analytics, and internal. Internal means it's just using the data internally. So this would be like libraries that were utility functions for parsing XML or other things. And then we created a model to predict people's likely privacy concerns and applied that to all 1 million plus apps. So talking about the libraries, the reason that we think this works really well is because there's actually a long tail of libraries too. So the most popular libraries are used by lots of these apps, and then it sort of goes downhill from there. And so, for example, here it's Flurry. It's still one of the most popular libraries. But if you compare it to this one, there's 120,000 people or apps at the time using AdMob, but only half that number using Flurry. And it also dramatically drops down from there. So if you manually label just the top 100 or 200, you actually will cover the vast majority of libraries.
I'm just surprised I don't see Google Analytics.
Well, they own AdMob.
AdMob, that is AdMob.
AdMob.
Yeah,
Okay.
yeah, that's why you don't see it.
Oh, nice.
Right.
Who owns Flurry? Do you know?
Flurry is now Yahoo.
Okay.
Yeah.
I'm sure they're all owned by one of the top.
Yeah, essentially, yeah.
Yeah.
But this also leads to another problem too. Like, before this talk, how many people have ever heard of millennial media or InMobi? Right. And see, that's sort of the problem is that we've been trying to figure out these user interface issues and how do you explain these things that people haven't heard of? Oh, yeah.
What do these libraries do?
Oh, okay. AdMob, advertising, Facebook, connects to everything. This one is some kind of logging.
So are they using the library for like the login, or like, I mean, I wouldn't just, as a developer, I wouldn't just like use Facebook's library unless I needed it.
Right. So they wanted
it
to.
A login service.
So you might do something like I don't think they were using it for OAuth. They'd probably be doing things like post to your person's wall or to be able to connect their friends.
Okay.
Yeah. But yeah, this is actually a good point because it's still sort of a coarse-grained analysis in terms of what they're specifically doing. Because, for example, Facebook you can do multiple things with, but AdMob is a little bit clearer as to what you're trying to do.
For serving ads.
Yeah, basically.
And these, okay.
Yeah. In the back.
You spoke about how you address the legal risks, but could you also say about potential ethical concerns about handing out these grades to thousands of apps? What if your grade goes out of date, or what if the grade is misinterpreted by the user, et cetera?
Yeah, some of our grades are definitely out of date because we've been trying to. First off, we did have a crash on our server thanks to some people who broke into it, and so we had to resurrect the server, and then we haven't updated our crawl in a while. So it's probably about a year or two out of date at this point. The other thing, though, related to what you're saying, is that we've actually only gotten positive feedback, even from developers. We've only had maybe 2 or 3 developers ask us to remove their apps. And in fact, like one of them was a teenager saying, well, I'm really embarrassed about the apps I created a few years ago. Could you remove that? Because I'm applying for colleges now. But beyond that, everything else has actually been surprisingly positive. So I think that addresses only some of the issues. But yeah, it's like how accurate are these too? So there's also that question. I will talk about some of the accuracy issues because we are looking at libraries and we're not looking at the custom code, like what exactly developers are doing at this point. But that's sort of the later work that I'll talk about in a few more minutes. But there's probably a lot more involved conversation, so let me just chat with you later afterwards. Okay, so here's an example of how the model works. The basic way to read this is it goes from negative to positive. Negative means that people have high privacy concerns, and then positive means that they have fewer privacy concerns. So basically, in the crowdsourcing, we had asked people, on a scale of -2 to +2, how comfortable are you with this? And so the way to read this is, so using your contact list for ads, you see as a score of -0.97. That means people are really uncomfortable with using ads, contact lists for advertising. But if you look at social networking and say coarse-grained location, it's 0.3, which means that in general, people are fairly neutral about how their location data is used for social networking. And so this is just the general idea, and then we applied all the different permissions and aggregated the scores together.
What do you consider coarse versus fine?
Yeah, so this is as defined by Google. So basically, the coarse-grained is if you're just using the cell tower location. So you'd probably get it on the order of like 100 meters or so, and then fine-grained is GPS location. So on the order of like maybe 10 meters or
so
less.
They don't separate GPS from altitude, barometric pressure, that kind of stuff?
Yeah, they can get that stuff, but we probably could check to see how often they use that stuff. But I suspect most developers don't use that.
Google gets it.
Well, yeah, Google definitely gets it.
Yeah.
So how do you account for things like under analytics where the coarse location is a lower comfortable than the fine location, and fine location is a subset of coarse location?
I think that's mostly an understanding issue too, because and also probably the apps that we're looking at. The challenge here is that do people really understand what the difference between fine and coarse location is? Right. And so it's probably partly a method issue, and probably partly because the apps that we're sampling, some of them were using coarse location, some of them using fine. And what this shows is just the aggregation of all the results there.
Oh, okay.
Yeah. So it's not that it's a strict subset in this case. It's just sort of what people said for that specific category. Okay, good questions. So this work has had a lot of positive impacts. So lots of press, governments, and some of the earlier work helped lead to Federal Trade Commission fines. So there's some people who made a flashlight app that's probably pretty annoyed with us. We found out Google does have something like privacy grade internally inside their own system. So I thought that was pretty cool. And then developers, there's even one press release sent out by developers saying that they actually try to improve their privacy practices because of this work. So this will also led us to think that shame is actually a pretty powerful kind of way of trying to improve the whole ecosystem, which I thought was pretty cool. Okay, let me go on to talk about protecting my privacy. This is another system that my colleague did, and now we're working together, so that's why I'm also talking about this. So this is done primarily by Yuvraj Agarwal. The idea here is that for jailbroken iOS and Android, you can add this app into your system, and then what it'll do is intercept these calls to sensitive data, and then it can also help you make decisions based off of that too. So for example, if enough people have made decisions on this, then you can also say, well, let's just see what the rest of the crowd did. And so in this case, for Kayak, it's just, okay, identity, you should allow that. Location, you should allow that. But for contacts, protect that. Don't allow that. And you can also do fake data as well, too. So I'll show you an example of fake data in the next slide. These numbers are actually from a few years ago, but they had over 200,000 people using iOS Protect My Privacy, over 6 million decisions, 20 different data types, and recommendations for 97% of the top 10,000 apps. So there was a really large number of people that was using this, and actually still are using this. Here's some more specifics. So if you look at what apps are protected, so you can see all the different apps and the kinds of data they're using. So it says identifier, location, contacts, and so on. You can also drill down on specific apps and see here's all the individual protections you can have. And if you want to, you can also set fake locations if you don't want them to really know where you are too. Now, one interesting finding that we had here with this is that developers, it turns out, didn't always know what the behavior of their own apps were. So there was a Flixter app. This was recently bought out, I think, by, actually I forgot who. But it's for movie recommendations and reviews. Developers contacted us and said that, hey, Protect My Privacy says that we're using contact lists, but we're definitely not using contact lists. And they, in fact, reviewed their own code, their source code, and they couldn't find anything with the contact list. But we analyzed the app behavior using a web proxy, and it turns out it was a third-party library that was actually requesting this. And so it's an advertising library trying to get all your contacts and probably trying to do similar things like what a lot of social networking sites are doing, figure out who you know, and then it also gives you more information about what your interests are and so on. So it turns out that the newer version of Flixter used a different library, ad library, so they removed that one. So it's some example of positive impact. But I think this is actually, again, a really important point that developers often don't know what their own apps are doing. Yeah?
So in this case, did they have to put something in the manifest that declared that? They had forgotten that they did that?
Yeah, so it turns out in iOS there's no manifest. In Android there is a manifest. So yeah, that's why they didn't really realize what this was doing.
But then there must be a user prompt, right, in iOS, and they haven't noticed? Or it looks like there's
this is before the whole user prompts happened too. But yeah, because of the whole scandal of Facebook and Path Mobile Social Network, then Apple iOS put that in afterwards, saying I'd like to use your location or I'd like to use the other stuff. So in some ways, this was really new at the time, but some of it has been eclipsed by the newer versions of iOS, but not the recommender system part. Yeah, good question. Yeah.
Did anybody do any put any thought into the types of people who would jailbreak their iOS phone and and their feelings about privacy?
Yeah, it's probably going to be much higher there. But yeah, so that's something that's probably very likely. And also the level of skill that it would take to do the jailbreaking and willingness to install this stuff. But it turns out that there are a large number of people who have jailbroken their phones. So if you look at the CITP, the network, so this is for the jailbroken stuff, there's a lot of people that are there too. So it's much higher than I would have expected. But yeah, that is a good question. Are there demographic differences between the two? Okay, so moving on. So here's some reflection after we had done these first two projects. So how much do developers actually know about what their apps are doing? And in general, how much do developers know about privacy? How else can we infer what an app is doing with your data? So I talked about the libraries approach, and we can also intercept these calls. Are there other kinds of things that we can be doing too? And then lastly, what are other ways we can protect end users? So I showed two different ways, but this also got the little hamster wheels going in our heads. What else can we do to protect people? So here I'm going to go to the process-oriented view of these apps. So start from developers. What do developers actually know, and how do we help them? So I'll talk about three different things: interviews with developers, a plugin we're making for Android Studio for Android developers to make it easier for them to deal with privacy, and lastly, a new kind of programming model that we've been working on too. So for developers, what we did is we interviewed 13 app developers and then just did a survey with 228 app developers. This is a really common design pattern for studies. First, you do a qualitative approach, and then you do a quantitative approach. So the qualitative is to understand the range of behaviors, and then you do the quantitative approaches on the things that you found to see how common those behaviors are. And so we wanted to see what kind of knowledge people had, what tools they used, what kinds of incentives, and were there good points of leverage too. So as you might imagine, a lot of people didn't really understand what these libraries were doing. And also, I didn't really mention this. Why are people using these libraries? Imagine you've made an app, and now you want to make money. So instead of trying to create your own ad network, which would be incredibly difficult, you say, okay, I'm going to take this Lego piece, which has all these advertisements, and can manage all this stuff for me, and just plug it in, and then I can start getting money out of that. So it's actually a really rational behavior on their part. But the problem is that they don't really understand what their things are doing. So we found out a lot of people had really inconsistent answers when we were asking them about their apps and what kinds of libraries they were using, because the inconsistent answers suggested that they don't really understand what's going on. A lot of them also didn't know that their apps collected data at all, too. So one kind of comment we have as suggested improvement is, if either Facebook or Flurry had a privacy policy that was short and concise and condensed into real English rather than legalese, we would definitely have read it. But they don't even have, a lot of these third-party libraries don't have any kind of legal kinds of documents to explain what's going on. Another thing we saw is that there's very low awareness, very, very low awareness of these existing privacy guidelines. So fair information practices, FTC guidelines, California Attorney General guidelines, they don't really know any of that. And so often they just ask people around them. It's like, hey, what do you think we should do about privacy? What do you think we should do? And it just sort of went from there. There's also a very low perceived value of privacy policies, as you can imagine, too. So mostly protection from lawsuits. I like this one. I haven't even read our privacy policy. I mean, it's just legal stuff that's required, so I just put it there. We also did a follow-up study looking at developers specifically. So what were their specific practices as well, too? So we interviewed 10 app developers about the specific practices, looking at the pain points and best practices when they're developing code. We also asked them to recount their most recent project that they're working on, too. And again, limited privacy knowledge. So people didn't know what to do beyond these privacy notices, privacy policies, and permissions. Often people just use Google, and then you can imagine the problem is that they just find one solution that seems to work, and they just copy and paste that without really exploring what are the right options. Or they just use what they used last time. It's like, hey, I used this location API last time. It seemed to work. Let's just use it again. So I think this is actually an open question for us as a community, which is, what should the best practices be for privacy? So if I ask, what's good practices for security, a lot of you would say, okay, you should use SSL and TLS. You should use encryption for data at rest. You should use strong passwords and so on. But it's actually not clear what the best practices are for privacy, too. So I think this is something that if we as a community could figure this out, then this would actually help things a lot. And to give a little bit more concrete example, it's a lot like Asimov's 3 laws of robotics. So you should not harm a human. You should obey humans and not let yourself be harmed. But there's a really big gap between that and, okay, what's the actual code, right? How do you translate these high-level goals into specifics of your code? And it's sort of the same thing. Like, we know the fair information practices, but how do you translate that into code? It's like, how do you minimize data collection? How do you explain purpose and other kinds of stuff? So we sort of know what the goals are, but not the specifics of how to do it. Other things, people really needed external reminders. So we saw some developers talk about how they forgot to add notices. In contrast, compare this to compile time errors. Your app just doesn't work if you don't fix that. Or Android permissions. If you don't stick a permission in, your app will fail really fast. So I think having those kinds of reminders definitely will help people pay attention to these privacy issues. There's also a lack of motivation, as I'm sure you've all noticed. So people are actually rarely contacted by users about privacy. In fact, none of them said they'd ever been contacted about privacy at all. There's also a rush to market, so privacy is deprioritized. One interesting kind of finding we had, too, is that people really need help with documentation. So you can imagine if you did have a privacy doc that said, here's what our practices are, that gets out of date really fast. And so it also gets worse, too, because you might have distributed teams. So you might have multiple team members. You might have different versions of your app. And you might also be using these third-party libraries. So keeping all this documentation up to date is also really difficult. And it seems to be a nice kind of pain point that we might be able to address. So here's the Coconut plugin we've been working on. The idea is Android Studio is the most popular integrated development environment for creating these kinds of Android apps. What we're looking at is how to use Java annotations, which is a feature in Java, to help people explain what they're trying to do. So document their data practices. So for example, what they're trying to do, the purposes. And then this plugin can also give them suggestions as to what they might want to do. Also, if we have these annotations, it can probably help with a lot of other things too. So for example, you might be able to have app policies that go into the app itself, and later on other people can check, is this app actually doing what it says it's going to do? We could also use better user interfaces too. If the app says, I'm only going to use your location for these reasons, that can be put in directly into the user interface. And might be able to auto-generate a lot of these text privacy policies too. So to give sort of a brief explanation of this, here's an example of the annotation. Here's the API for getting your location. And it says, okay, visibility, is it in the background or in the foreground of your app? What's the purpose? So we're trying to create a small ontology of these purposes where people can specify them. It says what the data type is, in this case fine-grained location versus coarse-grained versus other kinds of granularities. And also some human-readable strings trying to explain why you're using this data, how long you're going to keep it, how often you're going to query, and so on. Here's another example. So here's another example of annotation. And I know this is probably too hard to read, but what it's saying is that this person's saying, oh, well, this is going to be fine-grained location. And then the app can also say, or the IDE can now say, are you sure you really want fine-grained location? Have you considered using coarse-grained location instead? So helping people understand that, here's another design option that they can look at. So again, as we had seen, people just don't have a lot of knowledge of the APIs and these options, so it can help them explore this in a much easier way. And on top of that, we can also use the quick fix capabilities that's built into Android Studio. So saying, well, if you want to use another granularity, we can easily fix that for you. Right. Here's another example that shows the quick fix and also for unique IDs. Turns out in Android, there's at least 3 kinds of IDs. There's hardware IDs, there's app IDs, and then there's also advertising ID. And a lot of people don't know the difference between any of those, and so they just choose one that works, but it might not actually be the appropriate one. So a hardware ID might be your unique phone ID, but all they really want is just something that's temporary, like for advertising ID. And so here, by having people specify a little bit more about what they want, then we can also say, well, maybe you should consider using this other kind of ID instead. And lastly, we can also aggregate all this data together. So every time you have an annotation, now we can create an overview, a dashboard that says, here's all the sensitive data you're using, here's where you're using it, and here's why you said you're going to use it. And so this can help people understand the overall behavior of the app, even after you have distributed team members, after versions, and other kinds of things too. So we're actually doing the user studies right now. We've run about 15 people or so. So the feedback has been surprisingly positive. People haven't said that it was very burdensome. I know it looks like it's burdensome, but people actually found that it was actually pretty lightweight. And they did like it a lot too. So far so good. We'll see. Okay, so that's the second one. The third part about helping developers, this is a new programming model that we've been looking at. We're calling privacy streams. The basic insight we've had here is that most app developers actually don't need the raw, fine-grained data. So for example, we found by examining a whole bunch of apps, popular apps and some research apps, they don't actually need your GPS data. They want some transformed version, like what city are you in, what time zone you're in, or what block you're at, and so on. For contact lists, a lot of people didn't actually need your full contact list either. They only wanted one contact, or they just wanted things like how many people are in their contact list. Same thing with messages. They don't want your full messages. They only want things like what's the sentiment analysis, or did you receive a message from our phone number? Right? But you sort of see there's a mismatch here, which is that in Android, you basically say, I want everything or I want nothing. There's no in-between right now. So basically you get access to all messages or no messages. But as I was showing here, we actually don't need raw access to everything. You can see the one exception here is microphone. So this is for a lot of people recording things. So if you want the raw audio recording, then yeah, you need the raw stream. But there's also a lot of apps that are just doing a lot of data processing, so signal processing on there too. Okay, so here's the first part. So saying that not all developers really need the raw data. The second thing we also saw too is if you've ever done any Android programming, it is a royal pain. So you have different encodings. You have to process the raw data yourself. This is actually our code for trying to see how loud is it in a room. This code is actually borrowed from one of our previous research projects, which is trying to infer, are you sleeping or not? And we did use microphone, but we only need to know how loud it is versus what the actual raw data is. But again, there's a lot of things you have to deal with. So encodings, raw data, permissions, threading, and other kinds of things. So it's actually a real pain to actually deal with this. And you also have different APIs for different sensitive data too. So the microphone data is different from context, which is different from call log, and so on. So here's the basic idea of what we did. We're trying to see what if we can make privacy a side effect. If we can make developers' lives easier, the code that they're trying to get or the data they're trying to get, if we make it easier for them to get that, and if we can make privacy a positive side effect, then we can have a win here. So the basic idea is it's a little bit like functional programming or stream-based programming, if you've seen that before. And so here in this case, we're trying to say we want to get the audio data periodically at this time interval. Then we want to calculate loudness, and then every time we get loudness, then call this callback. So imagine it's like Unix pipes. You have a very simple kind of pipeline here. But the nice thing about this is not only does it make the developers' lives a lot easier, it also makes it easier for us to check the code and see what it's doing. Now, we don't know exactly what the code is doing, but we know it's only getting loudness out of it because we know that they only see the final part of this data stream. So going from audio here to the app. And then we can also generate English statements too. This app will only get access to the microphone loudness. So our hope here is that, again, we can make developers' lives a lot easier, but now we can actually finally generate some English-like statements that can help people understand the granularity of the data. And also, if we have some kind of purposes here, like this one, it can also help explain what's going on a little bit too. Now, you can also try this out at GitHub. Here's some of the results of our user study. So we had 5 different kinds of tasks, and we asked people to try to develop an app with and without privacy streams. So one thing you'll notice is that these blue bars, these are using the Android API. There's actually fewer numbers of people that were there. The reason for that is because we asked people, finish the app, finish one of these tasks, and then if you have time, finish another task. So the reason that there's fewer there is because fewer people actually finished the second task. Whereas with privacy streams, the amount of time is lower, as you can see. So the y-axis here is time, and more people will not only finish their task, they finish some of the other tasks as well too. So this is actually pretty cool. This is the first time people had ever seen our API, and they were already more productive than using the standard APIs, which is pretty nice. We also hired a whole bunch of developers to take open source apps. We hired them off of one of these not crowdsourced sites, but one of these consulting sites, basically. And then we asked them, take this open source app, modify it to use privacy streams, and then we ran it through our checker to see what the English statements would be. And so, for example, speedometer, so this app requests location to get speed. Weather app, it gets city level location. Album app, it gets all your local images. So these are examples of how we might be able to generate better kinds of explanations of what these apps are doing with their data. So stepping back, again, app developers seem to have really low awareness of what these apps are doing. So not a really great thing. And in fact, here's a really interesting Stack Overflow headline I like here. Only half of all developers out there have a formal degree. And so how do we help these people do much better in their development? In fact, we've also seen developers tend to be really good at functionality. I mean, you can get almost anybody who's done a few apps, and they're really good at creating the functional parts of the app. It's the non-functional parts that are really hard to do. So things like usability, because that cuts across all the app. Same thing with privacy and security and energy. So this is where I think there's actually a really nice opportunity for helping people by helping them with these non-functional requirements, which is increasingly becoming important these days. There's also this thing called Gruden's Law I really like a lot too. So Jonathan Gruden is this really amazing researcher at Microsoft Research, and he has this nice quote. When those who benefit are not those who do the work, then technology is likely to fail or at least be subverted. And so I think this is actually a really important thing. We could just say, okay, developers, you have to do more work now. But that's not going to be a really big win for them. It's like, well, why do I want to do this? It's a lot of pain. So if we can find better ways of aligning the incentives and making their lives easier, and also figuring out how to improve privacy at the same time, I think this could also be a really viable strategy. So like I was saying with privacy streams, what if we could just make privacy a positive side effect? Okay, so let's keep going on. So next thing I'll talk about very quickly, looking at inferring why apps are using your data. So I'll talk about just one line of work, so decompiling these apps and trying to figure it out. We're also looking at network traffic, and we also have some work trying to say, is this app targeting kids or not? Just the most important thing there is that the icon is actually surprisingly useful because kids, or apps for kids, they tend to have really a lot of primary colors in their icons. So that turned out to be one of the best features here. Okay, so going back to decompiling apps. Okay, so in the previous work I mentioned we can infer the purpose of what the app is doing based on the library, but what about the custom code the developers themselves are writing? So the insight here is compiled Java code actually still retains a lot of the strings inside of it, which gives you hints about the purposes. So class names, method names, class variables, and so on. So let me give you an intuition of this. So if an app is using location data, and we can easily tell if it's using location data because it's just a single system call, and then if we find strings that look like EXIF, photo, and tag, odds are high is probably geotagging your photos. Right? And that's really is the intuition, is that developers are going to have useful names, generally speaking, that help you understand what the app is doing. Now, there's a whole bunch of complications, so obfuscated code. We found out about 10% of the apps are obfuscated, so it's all scrambled. We can't really understand what's going on. There might be deliberate manipulation, but we're assuming that the app's developers are not doing it at this case, and we just want to see how well the technique works. And then there's also probably the most difficult one. There's a lot of lazy developers that use terrible variable names. Right? We found out in practice that's not really that bad, so it's sort of good. But yeah, so like I said, it does work better than you might expect. So what we did was first we categorized a whole bunch of these purposes. So what we did is we first collected a random set of these apps. We looked for apps that use location data, and then we said what are the main reasons they're using it in their custom code. So for example, searching for things that are nearby, customizing based on location data. So for example, when I get home, then change my screen or whatever, traffic information, recording your location, and so on. We also looked at contact lists too, so backup and synchronization, contact management, blacklisting people. I like this one too, fake calls and SMS, so getting out of bad dates. And then what we did is we gathered 600 plus apps, and then we just sort of categorized them. We tried to get about 20 instances for each of these cases for doing a machine learning approach. And here's the general pipeline of what we do. So we take these apps, we decompile them. So we try to go back from the actual compiled app to the source code. It's going to be sort of a rough version of the source code because it loses some data. We identify where in the code it uses sensitive data. Then we look at the words that are nearby, and then we train a classifier, and then go from there. So for example, if we find a name that looks like fine restaurant, we try to split it into individual words. We do all basic natural language processing, nothing too sophisticated. And then we also try to score what the most important words are using my favorite algorithm, TF-IDF. Yeah, in this part, we're not looking at third-party libraries. So again, just the custom code that developers themselves do. And so this, the main thing to take out of this one is that here's a classifier, and it gets about 85% accuracy in terms of doing this for trying to infer what's going on with location data. And for contact lists, it does much more. So I'll point you to the paper if you want to see a lot more details. But again, just want to convey the high-order kinds of ideas here. In terms of the specific location purposes that we have, it actually works pretty well. So in some of these cases, it does really well. So for location-based customization and transportation, we can get very, very high scores in terms of guessing what the app is trying to do with your data. But we also have some cases where it doesn't do that hot either. So searching for nearby places and recording, it doesn't do that well. And for contact list, it actually, I skipped the contact list one, yeah. But yeah, in general, it works pretty well. There's some failure modes. So for example, people do use bad variable names. And so in this case, for example, local, search, place, and find. So we misclassified this one as geosocial networking. There's also some weird software design patterns we've seen some developers use. So one is they just get location data all the time, and they share it inside their app for lots of different components. And so that is really hard for us to trace as well, too. So if we take a step back, some of the things that we would think about this is, can we systematize these purposes more? So a lot of the stuff I've been showing you about our purposes is sort of ad hoc. So, I talk about advertising, analytics, recording, contact lists, and other kinds of stuff. If we had a more systematic taxonomy, I think this could open up a lot of possibilities. So, you can imagine that if we had a systematic taxonomy, we can do stuff that I've listed down here. Like, what if these developers had to declare their purposes inside their apps? So, right now, developers just have to say, this app uses location data, or this app uses contact list. What if we required them to say, this app uses location for advertising, or this app uses contact list for social networking? If we had that, then we could also do a whole bunch of other things. We could start trying to check and enforce those purposes. We could use a whole bunch of different kinds of analysis techniques, so static analysis, dynamic analysis, even crowd analysis. We can have humans looking at them. We could even have new kinds of graphical user interfaces, maybe even crowd data as well too. So people really like using this kind of data for these purposes, but not these other purposes. But this also leads to an open question, like how do we know what's a good taxonomy? So, or more pragmatically, as the PhD students have been asking me, is like, how do we actually publish this work? So it's still an open question. We do have an initial iteration of this taxonomy, but there's also open questions, like how do we know it's complete? How do we know it's actually good? So this is something that we're still struggling with, even though I think it's actually going to be really useful. So happy to hear any kinds of ideas that you might have for this. Okay, the last thing I'm going to talk about is protect my privacy or enforcement. And we also have two different things here. I'll just briefly mention privacy proxy. We do have a crowd-based approach for helping with privacy. Basically, it's a VPN that runs on your smartphone. It intercepts all the network traffic, and it tries to find personally identifiable information. It uses a crowd-based approach so that we, as the VPN creators, we never see your data. The data is hashed and sent to our servers, and so we just get counts of how many times people have seen this identifier. And so if it's an identifier that only you see in the world, then we know that it's probably likely to be PII. But if lots of people see it, it's probably not PII. So right now, it's currently under review. I'm going to talk about this one, protect my privacy. So this is sort of our next study in protect my privacy. So again, I previously mentioned libraries. The idea here is, what if we leverage libraries even more? So right now, all the permissions that people do with Google and Android phones, or Android phones and iOS phones, it's an app and permission model. So allow this app to use this data, or disallow this app from using this data. So the idea here is, what if we use libraries as the leverage point instead of apps? Because if you deny location for AdMob in one app, the odds are high you're going to deny in other apps. It's very unlikely you would allow it and disallow it in another case. So this is a study we had with over 1,300 users, and this is the new version of Protect My Privacy for Android instead of iOS. So they used it 1 year. They were using it for 1 year with the old model, so that's just allow or deny per app. We also looked at the new model, so for about a month, so deny or allow based on library. And we also inferred the library at runtime via the stack traces. So the stack traces, again, they still have the strings inside of them. They tell you what the name of the library is. And so we just have to figure out a priori what all the libraries are and manually label those. And so, like I said, it's a long tail, so it actually works out pretty well. In fact, that's what this shows. So this axis is the library sorted by the number of times it's used by an app. And this axis is the number of times we actually see it. And so the number one library is AdMob, essentially, and you can see it's used by lots of apps. But if you get to like top 20 apps, right, here's like hundreds, and then it goes down from here. So if you only look at just maybe the top 20 or 30 libraries, you've actually covered a large number of these libraries in terms of their usage. This next one shows that a lot of these libraries, only the top 30 libraries are responsible for over 50% of the sensitive data access to. So if you just look up here, here's the cumulative distribution function of these. And yeah, again, it's not that many libraries that are responsible for accessing sensitive data. And in fact, this graph is a really funny one. So the way to read this one is, if it's at 0%, it means that the app itself, the custom code, is the part that's using the sensitive data. If it's at 100%, it means that it's only the library that's using sensitive data. So, and you can see there's only a few apps that are sort of a mixture of the both. So what this essentially says is about 40% of apps only use sensitive data because of libraries. And it's also very likely the number is going to be much higher than this too, because we only had a subset of all the apps that are out there, and because these are the apps that people are using. So it could actually be the case, again, that if we can address this percentage of the privacy issues, we can still sort of make advances, even if we can't address all those cases at the bottom. And so in our study, we also looked at how many fewer decisions would people have to make if they used this library-based approach. And so the way to read this is that if you made fewer than 30 kinds of decisions, then we would reduce the percentage of decisions you have to make by 3%. But if you're making 90 different decisions, do you want to allow this app to use this data and so on, and we block by library, then we can actually reduce the number of decisions you have to make by 26%. So it's still pretty much a good win. Now, there's a lot more details in the paper, so the questions are things like, well, we know we can do this, but is this what people actually want? Yes, it actually is, because we found a lot of consistency in people's decisions in blocking by library. So I think that this could actually be a really good way of trying to improve this data privacy.
Quick question.
Oh, yeah.
Isn't, AdMob basically fundamentally at odds with privacy? That's how they're serving you targeted ads. So if the user's basically, like those 40% you refer to, it's probably ads.
Yes.
So if I disable that, There goes
yeah,
the
what
ad
happens to the ecosystem, right? This is a fundamental issue that we've been trying to figure out as well too, and we don't know the right answer yet. So because you're absolutely right, the reason that we have all these free apps is because of all these ads and then the collection of data and so on. So it might be the case that we need to help people understand here's what they're trying to do and here's why. Another solution might be maybe they don't need the absolute fine-grained location. Maybe they just need to know city location or block level. A third one might be maybe there's other kinds of metadata that we're willing to share. Like maybe I'm willing to share I'm at a grocery store, but don't share the exact kinds of GPS data. So I think that there probably are a lot of these hybrid solutions that get us most of the way there without having to share every single bit of data that we have. But of course, the current garden path right now is it's easy to vacuum up everything, so let's just do that. So that also is sort of incumbent on us as researchers to figure out what are sort of these hybrid solutions that might be able to get the advertising ecosystem almost all the way that they want, while people are also still comfortable with it too. But yeah, it's something that we're not sure of yet. But you're absolutely right. We shouldn't just turn off all data for all these advertisers. Because
I mean, maybe we should, but I mean, that's probably what's going on there.
Yeah, it probably is.
Yeah.
So coming back to the recap and the key ideas. So I think we do need to figure out an ecosystem of privacy. And I think one thing that's nice is, with the new GDPR coming out, the General Data Protection Rules in Europe, a lot of this is probably going to happen naturally now too. So previously, it was really hard to incentivize and sort of figure out how to move the burden of privacy off of end users. But now developers do have a much stronger kind of incentive, so that's going to help out a lot. Again, I think we should push a lot more of these purposes, why the app wants its data, and it can help with all the different kinds of analysis and with these user interfaces. So I think that's going to be another kind of really good point of leverage, as well as these libraries. As I was showing you, it can help a lot with analysis as well as these user interfaces. In terms of ongoing work, so one is this DARPA Brandeis project. So it was a big surprise to me when we saw this. So we were one of the performers for this. But Department of Defense actually cares about privacy. And they actually had a really good explanation for this, which is that, we're right here right now, but there's all these amazing apps we could do in the future if we can legitimately address people's privacy concerns. And so they were looking at 3 big areas. So mobile, so we're part of the mobile team, Internet of Things, as well as enterprise, so large corporations. And so we're working on a team with privacy-enhanced Android. So looking at how do we incorporate all these new technologies into smartphones and make it much easier for developers, so differential privacy, function secret sharing, and so on. And then we're also our team's looking at specifically how to make purposes central to this entire process. So again, that we can foster an entire ecosystem. So a lot of the stuff I was telling you about, the developers and the analysis and other kinds of stuff is fitting in under this project. This last one I want to mention, this is sort of our crazy, wacky idea. This is sort of at the very, very early stage, so love any kind of feedback. But there's a lot of smartphone papers that have this kind of pattern. We downloaded 500 apps. We have some secret sauce to analyze them. And here's our paper sharing our results. But we're not sharing our code or our specific data set or anything else. And so it becomes impossible to build on other people's work and also really hard to replicate other people's work. So the idea here is, what if our group in CMU, but maybe other people too, could build an infrastructure to let anyone in the world analyze these apps? So we've already crawled 1 million plus of these apps. And so what if we kept them up to date and other people just upload analysis code? So obviously we have to check the analysis code to make sure they're not deleting our database, right? But if they did that, and then they could write up their papers and then flip a switch and say, I'm ready to share with the rest of the world. And now everybody else can more quickly build on that work. And so it now becomes like a community resource where everybody in the world can start innovating and trying to figure out what are the best ways of analyzing this stuff. And in fact, in some of my early talks with people want to go beyond privacy and security. I've already talked to people who want to analyze stuff for usability and accessibility and other kinds of things too. So this is something that, again, we're still in the early stages of, but I think this could be a really nice kind of community resource and really improve the state of the art. Okay, so that's pretty much it. So I have a whole bunch of colleagues would really like to thank. I'm only here for my good looks, so they're really the ones that did all the work. And we also have a whole bunch of sugar daddies that I should also thank too. So thanks to the DARPA, Google, CMU, Scilab, Ivy Research Office, NSF, and NQ Mobile. All right, thank you very much. Happy to take any questions you might have. Yeah.
Most of the users get their apps from the app stores.
Yeah.
So what do you think? What's the role of this app store maintainers, Apple, Google?
Yeah.
I mean, there are millions of apps. Do they check every app?